If we were in a physical classroom together, I would walk into class with some luscious and juicy type of citrus fruit. I'm a fan of a good blood orange or tangerine or clementines. I like the citrus fruits. But I would start to open up my juicy citrus fruit and I would ask students to raise their hand when they finally smell the juicy fruit. What I've done by opening up my fruit is that I've created a concentration gradient. The scent molecules released from my tangerine or blood orange are very concentrated around me. And without any help, those molecules will move from where I am, an area of high concentration, to the outer reaches of the classroom, which are the areas of low concentration. It's these two areas with a difference in concentration that are a concentration gradient. All concentration gradients want to become homogeneously mixed. When you die, you will decompose, and the molecules that make you will become homogeneously mixed with this earth and this universe. So your molecules will move from where they are in high concentration in your body to areas where they are in low concentration, which is at the outer edges of the universe. I think on a big scale sometimes. Go big or go home. Tonicity. This is the term that we had to get to. A solute is way more important than us in this class because solutes help us determine this term, tonicity. This is the measure of solutes. Solutes. Actually, this term doesn't care about the solvent. It's just concerned with the level of solutes. However, using some simple math, if I were given the percentage of a solvent or a solute, I could calculate the percentage of the other thing. But we need to apply these terms of tonicity: hypotonic, hypertonic, and isotonic. These terms are relative terms. They are not absolute, and they don't tell you anything about the mathematical percentage of solutes in the solutions. Let me show you this with an example. The beaker here over on the left contains a 10% solution. So it's a solution that has 10% sucrose in it, and that means it's got 90% water. The one in the middle has 15% sucrose in it, which is our solute, and thus 85% water. I'm going to let you figure out the last one. It contains 20% sucrose, and of course you can figure out what the percentage of water is. The first beaker is hypotonic to the second beaker, right? Right? It has less solute. This one has less solute than beaker 2 or beaker 3. Correct. And that's because there's a lower percentage of the solutes, making it hypotonic. However, this third beaker is hypertonic to the other two because it contains more solute than the other two. And thus, relatively, it is hypertonic to the other two. Now here comes the rub. Beaker 2 here is hypotonic to the beaker on the right. Beaker 2 here is hypertonic to the beaker on the left. And that's because these terms of tonicity are relative terms. The term that we use to define the middle beaker is not dependent only on the middle beaker. It's dependent on the beaker that you're comparing it to. And this is why beaker 2 is both hypertonic and hypotonic, right? This would be very similar to lining up three people of different ages and using the terms younger and older to compare them. But as a bonus with tonicity, we have this term isotonic, which means the same. No matter what, your cells strive for isotonicity because it is homeostasis.